Hello and welcome back to the Master Civil Engineering. In this video, you will learn that how to find the maximum axial compressive service load that a column can support using the AISC equations. I have been given a question which states that we have to determine the maximum axial compressive service load that can be supported if the live load is 2.5 times as large as the dead load, and we have to use the AISC equation for both LRFD as well as the ASD. Okay, and the column which we are using is round HSS 6.625 cross 0.25 of AST A500 grade B having yield stress of 42 KSI. Okay, and you can see the unsupported length of the column as 10 feet. Okay, so first from steel construction manual for this HSS, which is a round hollow section 6.625 into 0.25, cross sectional area is 4.68 inch square, least radius of gyration is 2.26 inch, effective length, okay, it's the effective length factor multiplied by the actual length. So for this column here, which is having one end fixed and one end pinned, so effective length factor is 0.8. so 0.8 times 10, which is 8 feet, is the effective length for this column. Okay, slenderness ratio is given as KL divided by the least radius gyration. So it's 8 multiplied by 12. 12 is, we are converting this 8 into inches, okay, because the radius of least radius of gyration is in inches. So 8 into 12 divided by 2.26, which is equal to 42.48, which is less than maximum limit of 200. Therefore the slenderness ratio for this column is okay. Okay, it's less than the maximum limit for a compressive member. Okay, after that, finding the slenderness ratio for ASTM A500 grade B steel, a modulus of elasticity which is 29,000 KSI, that is kips per square inch. Yield stress is 42 KSI. Euler's stress is given as pi square E divided by KL divided by R minimum whole square. So it will be pi square into 29,000 divided by 42.48 whole square, which is 158.6 KSI is the Euler's buckling stress for this column. Okay, also 4.71 times under root of E divided by Fy, which is 4.71 times 29,000 divided by 42. It's equal to 123.76. This is greater than KL divided by R minimum. So we have to use AISC critical stress equation E32, which is FCR is equal to 0.658 raised power Fy divided by Fe into Fy. Okay, Fy is the yield stress and Fe is the Euler's buckling stress. Okay, this is the critical stress. Okay, when 4.71 times under root of E divided by Fy is greater than KL divided by R minimum. Okay, so value of critical buckling stress is equal to 0.658 raised power 42 divided by 158.6 times 42, which is equal to 37.6 KSI is the critical buckling stress for this column. Okay, and the nominal strength will be equal to critical stress multiplied by the cross sectional area of this column. Okay, so it is equal to 37.6 times 4.68 is the cross sectional area, which you can find from the steel construction manual, which I defined in the step first. Okay, so the nominal strength of this column is 175.97 kips. This is the nominal strength. Okay, now using the LRFD, okay, so ultimate load for this column will be equal to 1.2 times dead load plus 1.6 times live load. So it will be so it will be equal to 0.9 times the nominal strength, which is 175.97. okay, and live load is 2.5 times the dead load, so it will be 1.2 D plus 1.6 times 2.5 into D is equal to 0.9 times 175.97. From this you will get the value of dead load equal to 30.46. okay, so simply maximum axial compressive service load will be live load plus dead load plus live load. So it will be D plus L. D is 30.46 and L is 2.5 into 30.46. So its value, that is maximum axial compressive service load, which this column can support as per the LRFD, is 106.61 kips. okay, and for ASD, okay, maximum axial compressive service load will be simply dead load plus live load, which will be equal to the nominal strength of this column divided by the safety factor. Nominal strength is 175.97 divided by safety factor for ASD is 1.67, so it will be 105.37 kips will be the maximum axial compressive service load which this column can support as per the ASD. okay, so this is how you can find the maximum axial compressive service load for a column using the AISC equations both for the LRFD as well as the ASD. okay, I hope this solution video was clear and effective and you definitely learned something new. If you still have doubts, you can write them in the comment box. I will try my best to answer your doubts. And if you found this video helpful, you can like this video, share this video with your friends. Thanks for watching Master Civil Engineering and stay tuned.